Oh, good job. I would have forgot that, Keith. Um, and our tech line is 800-827-9508, option 2. You may want to write my email address down. It's larry.lemons@galarson.com. There's some publications I'm going to reference in here that you may want to get. If you are interested, shoot me an email and I'll send them to you. Okay, so with that, we'll get things started. What we're going to cover today is service and startup. It's going to be focused on air conditioning. I didn't have anything in here on the heating section, but if anybody needs it, let me know, and we will take care of that. Let's see, are we muted here? Can you guys all hear me? Everything going okay on your end? Not hearing anything.
I can hear you.
Okay.
Loud and clear.
Okay, good. Just want to make sure I had somebody text or chatted on there. So anyway, with that, we'll get going. We're going to talk about Precedent Voyager up to 25 ton. As Larson Company, we only handle up to 25 ton units, but a lot of what's in here is good up to the 50 ton units in a lot of the bigger Trane commercial products. A lot of this is going to apply. So this should help you with some of that other equipment also. We're also going to talk about the electromechanical and the Reliatel units in the Precedent units. And of course, Voyager comes with Reliatel. Something that's coming down the road is called Symbio. We did a short class on it. It's not in the rooftops at this time, but it will be within, I would say, probably sometime this year. That's something that is not currently in the system, but it is definitely something that's going to be there before the year is out, from what I understand. And it's a lot like Reliatel. You know, it's got the same inputs, outputs, but it does have a display. It's got a capability. You know, and again, that's a whole other class. That's a whole other issue that we can deal with as we go down the road. But look for that. It will be coming in the rooftops sometime this year. And this is what it looks like. It's the Symbio. It's called Symbio 700. And again, it's going to have a lot of the same characteristics, but there's going to be a lot more to it. And again, that's for future reference. When that hits the market, we'll definitely do some more in-depth training on that also. But look for it. It's out there. So I just want to make you guys aware of that. Okay, so Reliatel. I'm jumping ahead. Okay, this is one of the books I was referencing right here, this Reliatel SVD, and that's an old publication number. The new one is like September of 2018, I believe. But this RT-SVD03H is like the Bible for Reliatel. If you guys want this book in a PDF format, let me know, shoot me an email, and I'll make sure I get that to you. These other publications are install books and service packs. They're available on Comfort Site and DealerNet. It's kind of specific to the units, but if you need this particular one, send me an email and I'll shoot you the books, okay? It's almost impossible to work on Reliatel without it. So what is Reliatel? Reliatel came out sometime around 2003. It's the name of the system that is in a lot of our rooftops that are 12.5 through 25 ton. It's in our Precedent units, you know, unless it's an electromechanical unit, but it's a combination of controls that link together to give us different options. There's options modules, there's economizer modules, and they all communicate with each other. So as soon as you plug a board in, it auto identifies and the system starts to communicate, and it operates based off of these inputs. And that's kind of what we're going to talk about as some of the troubleshooting this afternoon. The RTRM is the main board on the system, and that's the Reliatel refrigeration module. It's the main module. It's the base module that the system needs to operate, okay? So once we have the RTRM in place, we can add gas heat modules, we can add economizer modules, we can add options modules, we can add communication modules. Every time we add or take a module away, the main board, the RTRM board, will actually auto-configure and change its operation based on what it sees in the system. So if you plug in a system and it has 2 contactors, it knows it has 2 compressors. Okay, if you plug it in and sees 1 contactor, it knows it has 1 compressor. If it sees an economizer module, it will operate as an economizer. If it's not there, it'll operate as it's not an economizer. So ultimately, you can have 1 board that fits all these units, which is been very nice. So a 3-ton unit takes the same board as a 25-ton unit. It just auto configures based on the configuration, the completed ground circuits, and works off of that basis, which we'll touch on a little bit more as we go. So again, it's a communicating system, works off a Modbus. Typically J4 on the RTRM, which we'll get into in a little bit. There's 2 black wires, a blue and a red, and the 2 black wires are our communication wire, and the blue and the red are 24 volts hot and common that keep the system active. That's what powers the system. So, all right, the Reliatel board looks like this. Like I said, it's been around since 2003, somewhere in that area. It can operate on a zone sensor. It can operate a conventional thermostat. It can operate, communication. And it's all based on a hierarchy. And the way it works is if it's a 1 through 5, if it's like this, that's a 5-volt DC communication system. Now, the thing to remember is when this is connected, this 1 through 5 right here, the rest of these terminals really are deactivated. They don't do anything. So if we have wires on 1 through 5 and you're up on a rooftop and you try to jump R to Y or R to W to make this thing work, it's not going to respond. It's not going to do anything. The board recognizes this as the priority call, and anything below this call in these terminals is deactivated at that point. Same with communication boards. If you have a LAN-talk card or a BACnet card or a TCI card for a zoning system in here, and it's tied into J4, which is going to be over here. Some of the new boards, this is an old picture. A lot of the new boards have J10 terminals on them, and that's what the communication terminal is. If there's a communication card in this rooftop, it ignores all of these inputs. These inputs will do nothing. So again, there's a hierarchy. Communication card is priority 1. The DC voltage on 1 through 5 is priority 2. And then of course 6 through 14 would be your base sense 119s, that's priority 3. And then the lowest priority is going to be a conventional thermostat. So if any of these other terminals or this LAN-talk card is in place, these are deactivated terminals. So that's important to remember when you're working on these units. On the 1 through 5, again, this is a 5-volt DC system. You could actually disable 3, 4, and 5, take these wires off of here. And terminal 1 and 2 will operate the system. It'll do heating, cooling, staging, economize. It'll do everything it needs to do off of these 2 terminals based on that DC input. It's going to try to maintain 71 degrees heat, 74 degrees cool. It's going to do auto changeover. It'll switch back and forth between heat and cool as it needs to. And it will have continuous fan at that point. So if you want to run a system with just 2 wires in temporary mode, that's probably the simplest way to do it. That's a 10K input, so it's 10K at 77 degrees, and you could run this thing all day long like this, okay, on those 2 terminals. So if I add terminal 3 and I run a 3-wire thermostat on this DC voltage, then what happens is the input, the 1 and 2 measure the temperature in the space, and number 3 controls the temperature, okay? So It's going to maintain a cooling set point and the heating set point at the same time. And there's going to be 3 degrees difference in the set points. So in other words, if I have 3 wires and I set my cooling set point at 74 degrees, the unit will automatically maintain 71 degrees heat. It'll switch back and forth by itself. So you can run the system with a 3-wire thermostat, and that's how it's going to operate, okay? If you add the 4-wire, which is your mode, now you can switch it back and forth between heat and cool manually, but it's still going to maintain that heat and cool set point on terminal number 3, okay? And then, of course, if you add terminal number 5, now you can set the heating and the cooling independently and operate the system, you know, however you need to do that. So when you have a 5-volt DC thermostat, it changes the operation. It gives you a lot better control over the system. Okay, so the next control that we would use would be like a BaseSense 119, a digital control. And if you go up on a rooftop and you see wires on 7, 8, 9, 10, 11, 12, 14, that's basically what you've got. Now it's a 32-volt DC control, okay? So what that means is 7, 8, 9, 10 are actually indicator wires. And this gives you your status, your heat, your cool, your system status, you know, service status. Number 11 is your common wire. Number 12 is your communication. So now it becomes a communicating thermostat, and all the communication is done on number 12. Number 14 is just there to light up the display on the thermostat. So these are all 32-volt DC terminals. That's a 14-volt or 24-volt AC terminal. And that's, again, that's just there to light up the display on the control. And that's hierarchy too. So with this thermostat connected, these terminals are still deactivated. You can't use these terminals to do anything. That they won't respond. The lowest hierarchy on these is the 24-volt control. And if you guys put a 24-volt thermostat on here, just make sure it's a good quality thermostat. These rooftops do not like Nest thermostats. I've had some issues with those. So power steering thermostats are out of the question. You need a powered thermostat or a battery operated thermostat. And if you wire in a conventional thermostat on these units, it wires like any other unit, you know, red Y1, Y2, W1, W2, G. If it's a heat pump, you got emergency heat and switchover valve also. But, you know, typically wires like any other thermostat at that point, okay? And that's basically the connections on this thermostat or on this RTRM board. All right, some of the older boards, this is the microcontrol that we used from probably about 1991 until 2003, but this is in the older rooftops. It has the same capabilities, pretty much did the same thing, pretty much operated the same way. The difference was that this board did not have the thermostat wires attached to it. So if you wanted to use a conventional thermostat, you had to use a thermostat interface board. On the Reliatel board, it's built onto the board. And on the old microcontrols, it's not built onto the board. It has to be added in the field. And what you would see on the old units is the 1 through 5, you know, this terminal strip on the side. But it did the same thing. 1 through 5 is your 5-volt DC circuits, okay? You get 6 through 13 or 6 through 12. Same thing. Here's your 32-volt DC circuits right here. When you got into these, you would see we'd have thermostat or compressor disable. So if this brass jumper is out of here, the compressor won't run. If this brass jumper is out between 16 and 17, that's an emergency stop, okay? If this brass jumper is out, that's your supply air sensor, okay? So when you're working on the older equipment, look for these brass jumpers. If they're not in there, then there may be an additional control that we don't know about. Spring maintenance, this is probably one of the things you want to check. Make sure these screws are tight, make sure the jumpers are in place. If there's wires on 16 and 17, typically that's a smoke detector. You want to check that, make sure that circuit is closed. One of the things about the Trane and American Standard rooftops is, even though we have an emergency stop, if the smoke detector is open, the light's still going to be on the board. We feed that board from a couple different locations, so the light's still going to be on the board. On the newer units, on the Reliatel units, you can see the board's quite a bit smaller. We don't have the 14 terminals on the board because if you look back at the Reliatel board, we put them all on the board. Okay, so that 1 through 14 is now on the board itself instead of on this terminal strip, but they basically, again, do the same thing. We have compressor disable, and we 1 and 2 here, we have emergency stop here. I always tell you guys, if you go up to the rooftop, it should look like a capital E if all the jumpers are in place, okay? Test 1 and test 2 is still there. That hasn't changed since probably about 1992. And we'll go into test mode in a little while to explain how that works. But this will be the new units that you're looking at today. Now, you could have more of these boards. It could go 1 through 6, and then you might have 7 through 12. Well, that might be a dehumidification unit. And it might go 13 through 19. You know, it might be more additions, and there might be supply air sensors, fan proving switches, that kind of stuff. So the minimum you're going to see on a Reliatel is this 6 terminal strip, but you could see more based on the unit. And again, we'll touch on those as we go here. The zone sensors, these zone sensors are 5-volt DC zone sensors, and you know, they look a little different. Times have changed. The finish is a little different, but these old zone sensors will work on the new equipment. It's just a 5-volt DC. It's a potentiometer with slides, and it works off of that, that principle. If you want to test a zone sensor, again, in the Reliatel book, there's a detailed explanation of how we do this. But if you go to the zone sensor and you test terminal 2 and 4, and 2 is always our common on these units, that's our common wire. So on terminal 2 to 4, that's our mode input. So what that means is it's going to tell us, are we in heat, cool, off, on, you know, what mode are we in? And in the book, if you look at this, I'm going to back up a second because this was a 0.942 volts DC. So if you look at a 0.94 volts DC, that tells me that the system is off and it's in the auto position for fan, okay? If I read 1.64, we'd be in a cool mode and the fan would be in auto. So all of those DC voltage inputs to that board mean different things to the board, and the board will respond based on those inputs, okay? Now you can also ohm these out. So if you don't have power there and you want to go from 2 to 4, you can ohm them out. So 7.69 K ohms is, if you look at the chart in the book, that's fan is in auto and system is in auto at that point. If the cool was on and the fan was on, it would be 1332 ohms. So that's how you can check these out to make sure they're okay. The most common thing that goes bad on these units are these slides right here, especially in restaurant applications. They'll get grease or dirt in them, and a lot of times they'll just quit working. Simple thing to do is take some contact cleaner and just, you know, spray these out, clean them up if that's the case, or replace the control. All right, so if I go from 2 to 5, 2 to 5 is my heating set point, okay? So if I read 2 to 5 and I've got 2.358 volts DC on those 2 terminals, if you look at the board, 2.358, yeah. Voltage is going to be, where are we here? 358, somewhere around here. So we're looking at about, what, 79 degrees. So that is my set point. It's telling me that voltage is telling me my set point is at 79 degrees at that point. Oh, sorry, going backwards, 51 degrees. got my chart in here backwards. But anyway, 2.35 was going to be roughly 51 degrees. So if I go from 2 to 3, 2 to 3 is my cooling set point, and it's 2.32 volts. 2.32 volts is going to be right about here. So my cooling set point at that point is set for about 49 or 50 degrees also. So that would mean both my slides are probably all the way to the bottom on that thermostat, but that should give me the equivalent. So if this is off, if I'm reading 2.93 volts and it's, it's off in the space, or the AC is not coming on, it tells me I may have a bad control at that point. So. And then 1 to 2 is my actual space temperature. This is kind of nice because if you have these on a rooftop, on the rooftop, you can actually take a voltage reading and it will tell you what the temperature is in the space. And in this case, 2.52 volts going to this chart is going to tell you that 2.52 should be 76 degrees in the space at that point. So if you go into space and it's 85, 90 degrees and you're reading this voltage, well, then you know your zone sensor is bad and it's not reading properly. So again, real simple way to check these out. And again, if you didn't have the power on and you wanted to ohm these out, if you look right here, 10K at 77, that's pretty standard through most of the rooftop equipment. So you can ohm them out and make, see where you're at also. All right, another voltage that's very important when you're working on these systems is the Modbus voltage. If you look at this is J4 on the board right here, and here's the plug I was talking about earlier. There's 2 black wires and a blue and a red. Okay, the blue and the red again are the power, 24-volt power, and then our Modbus are the 2 black wires. And you should read 9.6 to 10.7 volts DC. You can't really read what's going on in these wires because it's digital communication, but you should see that 10 volts roughly there to tell you that the system is up and running. Now, if you see 16 volts, you may have an open circuit. If you see 5 or 6 volts, you may have a grounded circuit. Okay. The nice thing about DC voltage is we don't burn out a board when we have a short. It just brings the voltage down in most cases and tells you that we have a problem in the system somewhere. Process of elimination, start unplugging boards and see if the voltage comes back. It'll kind of point you in the right direction. But this is kind of what you're looking for. If you look between the boards, it's J4 on the RTRM board, but on the options module, it might be J5. On the communication board, it might be J6. But it's basically this communication bus follows its way through the system. Just like it shows on the wiring schematic here. So on the ignition module, it's J5. Oop, back up here. So J5 is what goes to the ignition module. And if you look at how it follows through here, we've got the 2 black wires, the red and the blue goes from the RTRM to the ignition module. That follows through. The black and blue wires goes to the LCI, the LAN talk communication card, the RTRM, the RTROM, or the RTOM options module. So if you follow this bus through the system, you'll see it daisy chains from board to board and carries that communication through the system. Some simple checks, and you can find out whether or not we've got the proper communication voltage. We've also got a TD5 that's available to give you better diagnostics. I think we'll cover that in a little bit too. So, but on the schematic, again, the Modbus is the red, the blue, and the 2 black wires. It just follows through the system. The economizer module is a little bit different. On the Modbus, you go from the options module to the economizer. That's going to be like a 2-volt DC. So in other words, it could be anywhere from 0.5 to 2 volts. So when you get to the economizer module, the voltage might be a little different. But again, it follows through the two blacks, the blue and the red. It just daisy chains back to the economizer module. A good troubleshooting tip for the guys in the field. If you're out there, the system's not running, things aren't doing what they're supposed to do. Most of the time it's in the economizer module. If the economizer module gets water damage or gets water in it, or for whatever reason stops working, it will pull down the communication bus voltage. And when it does that, it kind of disrupts the communication to the main boards. I have seen cases where the economizer module will actually not allow the heat to run. So make sure if you've got some unusual things, just do some process of elimination. Turn the power off, unplug the economizer module, flip the power back on. As soon as you turn the power back on, the board's going to see that the economizer is no longer there. It's been taken out of the circuit, and it will operate like there's nothing there, like there's no economizer there. If system starts working fine, you got to shorten the economizer. Okay, and this goes back to the microcontrol stuff too. Difference is Reliatel has 4 pins. And the old microcontrol has like a 16-pin connector up near the roof of the unit. So, but it does the same thing. If you turn the power off, unplug it, turn the power back on, it will reactivate as if the economizer was never there. So, again, simple troubleshooting things. When you get into the options module, which we'll talk about a little later, we've got fan proving capability, we've got clog filter, we've got frost stats. We've got smoke detectors. We've got all kinds of things in there. One of the things you'll notice is when we get into our smoke detectors and our frost stats, these are normally open switches, a little different than what we're used to. When a frost stat fails or a smoke detector trips, it closes that circuit, and that's what trips the options module into shutting down the unit. Usually on J7 on the options module, if the smoke detector is tripped or the frost stat is tripped, if you just simply unplug them and open that circuit back up again, the unit will start running and take off, and everything is fine. So just remember, we do it a little backwards on ours. These are normally open circuits that close. The airflow switches and clog filter switches are normally closed, but the smoke detector and the frost stats are normally open, so a little different. So keep that in the back of your mind when you're working on these systems. All right, so when you get to a job, the first thing you want to do is, of course, check power, make sure everything's okay. There should be 24 volts at pin 1. These are all 24 volts hot right here. So if you notice that jumper is gone from here and there's no wires on here, that means compressor 1 is not going to run on this particular. But this is definitely going to be at 24 volts hot to chassis. Everything on our rooftops is grounded to chassis. So you can take a reading from anywhere in the system to chassis. One thing I will point out, this is an old slide. Some of the plugs have gotten smaller. So if you don't have needle points for your meters, you probably want to get a hand on them. It can make your life a whole lot simpler when you're up on these jobs, especially Mitsubishi if you do any of that stuff. All right. There's also diagnostics on Reliatel, and the key to the diagnostics is don't reset the power until you figure out what's going on with the rooftop. So if you get to a rooftop, it's locked out, and nobody's reset the power, just stop right there, take some voltage readings, and you can get some idea what's going on. Now the diagnostics will be there whether or not it's a Lontalk card, whether it's a 24 volt control, DC control, it doesn't matter. The diagnostics will work no matter what. And the way they work is on the strip down here, terminals 6 through 10 have diagnostic measurements. 6 is your common, and it's a 32 volt DC circuit, so you want to make sure your meter's in 32 volts DC. And if I wanted to go between terminals 6 and 7, this is my heating diagnostics, okay? So if you take a voltage reading on 6 and 7 on these units, and it's below 1 volt DC, what that means is you don't have a call for heat at that point. There's nothing calling for heat to make the system run. Okay. If I go to terminal 6 and 7 and I see anywhere between usually 28 and 32 volts DC, that means I have an active call for heat at that point. I should be in a heating mode. Inducer should be on. If it's electric unit, electric heat should be on. Something should be heating at that point. That's an active call for heat. Okay. If I'm in a situation where it's fluctuating between 0 and 32, if you put your meter on there and it's jumping all over the board, 0, 32, 0, 32, what that means is you are in heat fail at that point, okay? And a heat fail means that something happened in the heating circuit and the system's down. Now, when you go into a heat fail, what it's going to do is it's going to shut the system down. It's going to shut the fan off, the heat off, it's going to lock you out, and it's just going to stop working. Okay, so typical heat fails on these rooftops could be TCO2 is opened, which would be your thermal cutout or your limit is opened. Your zone sensor switch could be bad if it's an electric heat on a heat pump, or could be a defrost problem. But typically, on our gas pack unit that we deal with in the Midwest anyway, it's a limit trip, could be a flame rollout, could be an inducer pressure switch, could be a gas heat failure. It could be flame current not sensed properly. And basically the high limit trip, I don't know if it's coming up here, but when the high limit trips 3 times on a call, within that, I think it's within an hour, it will actually shut the system down, lock it out, throw you into heat fail. So typically when you see heat fail issues, it's got to do 90% of the time, it's probably the high limit or the TCO2. On these units, there's a high limit by the burner, and the TCO2 is on the blower housing itself. Either those are open, or sometimes from vibration, the one on the blower will go bad and actually open, causing the same situation. But definitely the high limit is the first place you want to look. Okay. And that could be anything. Could be a bad limit switch, could be dirty filters, could be a loose belt. It could be anything, but that's the direction you want to take a look when you see these situations. All right. We also have cooling diagnostics that are available. And again, this, before you reset the power, take a look at these diagnostics and it will point you in a direction, at least give you some idea what you're looking for. So if it's a cooling call and I go to terminal 6 and 8, in this case for cooling diagnostics, it will tell you what's going on. So if I have less than 1 volt DC, I have no call for cooling at that point, okay? If I go to terminal 6 and 8 and I see 32 volts DC, okay, that means I have an active call for cooling. The reason I put this picture up here is because these diagnostics are also available on the old Voyagers, you know, back to 1992. So not just on Reliatel, but that diagnostic is also available on the old stuff too, with the 1 through 18 or 1 through 20 terminals on there. So if I have a 32 volt DC, it tells me I have an active call for cooling. Now, am I going to have a compressor on at that point? It depends on whether or not you're in a economized mode. It could be economized at that point, but something should be asking for a cooling call. You should be economizing, or you should have a compressor on. Something should be happening at that point, okay? If I'm in alternating mode, again, 0 to 32 or 0, yeah, 32 volts DC, 28 volts DC, if it's jumping back and forth, that means I'm in a cool fail, okay? Cool failures, again, it could be the cooling set point on the thermostat has gone bad, temp sensor failure. It could be the contactors, you know, compressor contactor 1 or contactor 2 circuit problem. These units, and we'll talk about this in a little bit, these units are looking for 6 to 12 ohms of resistance on these contactor coils. And if you got a coil going bad, you could go into a cool fail. So you always want to check your contactor coil, make sure that the ohm value is correct on the coil. Could be your high pressure switch is opened, but typically it's your low pressure cutout open during the 3-minute minimum on time for consecutive compressor starts. So again, that could be low charge, that could be dirty filters, loose belts, could be anything like that. But if you have a situation where the low pressure is cutting out, you'll go into a cool fail also. So those are all things that you should look for when you're working on these rooftops. All right, I said earlier, and I just want to point this out, we feed the board from 2 or 3 different places. So just because the light is on the board doesn't mean we can't be in a cool fail, we can't be in a locked out situation. But if you look at this, 24 volts comes directly off the transformer for the control side of the system, and then it tees off, and this I believe goes over to the phase monitor. This one feeds the low terminal switch here, so we've got that 24 volts on that 6-terminal low pressure switch. It also feeds number 1 on the board. The number 1 terminal on the main board is also being fed with that. So again, it's fed from, it looks like in this case, about 4 different spots we could be getting power. So again, just because the light's on the board doesn't mean that we don't have something else going on in the system. All right, on the terminal strip, and I just want to point this out, this is number 1 right here. Okay, that has 24 volts, or should have 24 volts. One of the first things I ask guys in the field when you're working on these is go to this pin right here, and if you look, they've got a place for you to put your meter on the backside. Look for 24 volts there. If the light's not on the board, and you have 24 volts at this pin right here, your board's shot. It's time for a new board at that point. You stop right there. If there's 24 volts here and the light's on the board, well, then we continue on to the next check. Okay. Now, these all have different inputs, and it's in the schematic. Your pressure switches are inputted into here. They're all the different inputs are on the schematic, which I'm not going to get into right now, but we're going to talk about the outdoor air sensor, which is right here. Okay, so the outdoor air sensor is a 5-volt DC circuit also. When this is plugged in, there's a 10K sensor at the end of this, and usually the sensor is located near the foot of the compressor. Some of the older units, it was located in the corner post on the right side, kind of tucked up behind the control panel, a little hard to get to. But the outdoor sensor manages a lot of stuff. It manages your low ambient operation. It manages your economizer. It tells the unit, exactly what the outdoor temperature is so that, we can do different things. Now, when we go into low ambient operation based on the outdoor sensor, if it's a single fan unit on the condensing side on a cooling call, that fan will shut off at about 55 degrees, okay? So if it's below 55 degrees outside, that outdoor sensor is going to tell the board, shut the condenser fan off, and we're going to operate without the condenser fan below that temperature. If it's a dual fan unit, okay, it's going to be at 40 degrees. And when you work on a dual fan unit, what you'll see is the outdoor sensor will basically tell the board we're below 40 degrees. Shut one of the condenser fans off, the other one will run. And that fan's going to windmill backwards. The one that's not powered is going to windmill. If the temperature were to warm up in the call, what it will do is it will shut that first fan off for, I believe, 7 seconds, and then restart both fans together at the same time. So the outdoor sensor is there for that. It's also there to tell the economizer when to economize, based on the outdoor temperature. So it's a real important piece of the system. Now, if I take the outdoor sensor off, if I cut the wire or unplug it, we lose low ambient. So now the condenser fans will run all the time. The economizer will not run, okay? The other thing that it will do is it will cycle the compressor. So if you're in a low ambient condition and you know the one fan is off, the compressors are going to have a defrost cycle. So every 10 minutes, the compressor is going to shut down for 3 minutes. Okay, so it's 10 minutes on, 3 minutes off, 10 minutes on, 3 minutes off. And that's standard. So if you're up on a roof in colder weather and you see that happening, that's what it's supposed to be doing, okay? But anyway, the outdoor sensor controls all of that. It's a 5-volt DC circuit. You should read a specific voltage. And again, if you go to the book and look at the chart in there, it'll tell you that this probably means, I don't know, maybe 40, 50 degrees. I'm just guessing off the top of my head. If you disconnect that wire, excuse me, if you disconnect that wire, what you're going to see is it's going to go to 5 volts DC, okay? An open circuit, the nice thing about DC circuits is when they're open, they run 5 volts. When they're shorted, they're at 0 volts. So if you are looking at a DC circuit or a sensor, you should read somewhere between 1 volt and 4 volts typically on most of the systems. But that's a way to tell that your board is actually working right. If I were to unplug this and I only read 1 volt on the board, it would tell me my board's not giving it the right signal, and I have a board issue at that point. All right, another really important thing is voltage. Okay, so when you set these systems up, make sure we get the tap on the correct transformer tap. Now on a Precedent, there's 1 transformer that controls the low voltage side, and on a Voyager, there's 2 transformers. Okay, there's the 350 VA, the big transformer. That one controls just the inducer and the igniter. That's just there for the heating side. And on the low voltage, it just controls the low voltage side of the circuit. So the red wire stays on the common. The blue wire is what you move. Don't move the red wire. If you move the red wire, it lets the smoke out. They come factory shipped for 240. If it's a 208 system, make sure you move that over here. Okay, it's important because if you don't move it and it's a 208 system, you're only going to get 21 volts on the control circuit. It might make the board do some strange things. On the igniter side, on the inducer side, the inducer is going to run a little slower. The igniter is not going to get as warm. Okay, so make sure we get these on the right tap. And I've seen these in the field 18, 19 years, and nobody's ever changed them, and they've had issues with ignition or control issues over the years. So even when you're doing a maintenance, it's something worth checking. But again, move the blue wire, not the red wire. Okay. All right, we talked about you know, this terminal strip before. It's got the test 1 and the test 2 that's been there forever, as well as the test 1 and test 2 on the new units, on the Reliatel units. Okay. They do different things based on the units. So this kind of shows on the new units, we've got a sticker inside the unit based on whatever's in that unit is how the thing will go into test mode. So the first step is fan. So when you jump out, back up here, when you put a jumper across test 1 and test 2, and this is, by the way, this is 5 volts DC right here. And this is 24 volts AC. Try not to jump these and short these together because it causes problem, lets some smoke out of the system. But jump these out. A lot of guys will use a quarter, call that the 2-bit tester. Or you can put a jumper wire on here and just short these two, test 1 and test 2 together, and it will go into test mode, okay? And when it goes into test mode, the light will start to blink on the main board. On the older units, it's going to be the red light. And on the newer units, it's a green light, but it will start flashing once per second. That tells you that the unit went into test mode, okay? On the new units, you're going to energize the fan, okay? But if the fan happens to be a DC drive, you know, digitally communicated fan or a plenum fan, it's only going to run at 50%, okay? And that's important to know. If you're doing air balance, that you turn the fan on doesn't mean it's going to full speed. And we're going to talk about setting up the fan speeds in a little while. So, but test 1 is is going to be fan. The next step will be economizer. It will drive the economizer open. The next step will be first stage cool, second stage cool, third stage cool if you have a three-stage system. Some of our units will actually operate as three-stage units if you use a Trane DC control. But if you use a conventional 24-volt control, it will only operate as a high-low, so they do operate differently. So what you're going to do is put a jumper on there, and if you leave the jumper on there and just wait, every 30 seconds it will step to the next level. So if I put a jumper on and I see what it's doing, it will bring the fan on. 30 seconds later, it will test the economizer. 30 seconds later, it will go to stage 1 cool. 30 seconds later, it'll go to stage 2. It'll walk its way through that. Anytime that I pull my jumper off in the middle of this test mode, it will stay there for 1 hour. Okay, so if I get to high stage cool or I get into heating and I pull the jumper off, it will stay there for 1 hour. After 1 hour, it will go back to normal operation. Okay, so if I want to jump it through a little quicker, what I can do is put the jumper on for a couple seconds and take the jumper off. Put the jumper right back on, force it to the next step, take it off. You can force it through a little quicker by doing that. And again, anywhere along the way, if I stop, it will stay there for 1 hour. If I reset the power and turn it back on, it will pull itself out of test mode and go back to normal operation. If I turn the unit off with a jumper in place, if I've got test 1 and test 2 jumpered, and I turn the power back on, it will ignore the jumper and just go back to normal operation. Okay, so there's a few different ways you can put it in test mode. There's also a third way. It's called, if anybody has a decade box, which are few and far between these days, you can set your resistance to these different values and put the jumper on test 1 and test 2. And if I want to go to high stage cool, I just put a 15K setting on there, or I get a 15K thermistor or resistor and hang it on there, and I can force it right to high heat without jumping through all the other stages. Okay. If you leave the jumper on there, again, it'll stay there for a short time and then pull itself out of heat. If you take the jumper off or the resistor off of there, it will stay there for 1 hour and then go back to normal operation. So in the test mode, there's different ways of getting to different things. One of the things that you want to remember is when you're setting up airflow, be aware of these speeds, these fan speeds here. If you're doing an air balance, you want to make sure you're in at least second stage cool, third stage cool, or heat to make sure we're getting the 100% airflow. I get this call quite often where the guys will turn the fan on, throw it in test mode, put the fan on, and then the air balance test doesn't pass. You're only getting 50% on some units. Okay, if it's a belt drive unit, it's not a big deal. They got 1 speed and that's it, unless you're using a freak drive. But on some of the DC motors, you have to kind of make sure you know which speed you're at. So, any questions on that? Anybody have any questions? I'm going to just take a quick look at chat here and see what's going on. So. Looks like we're up to date. Everything looks good. Okay, good. All right, so we have some different units. Also, we have some dehumidification units. I'm not going to spend a lot of time on these. In the advent of all the new efficiencies, we've gone to expansion valves on everything, but we have a dehumidification unit that has 2 condenser coils. And the reason I point this out is because the primary condenser coil is for cooling here. But when we go into dehumidification, what we do is we bypass the condenser gas through this second condenser coil, and then we run the evap coil and the condenser coil at the same time. This evap coil is slightly larger than this condenser coil, so you can overcool a space if you're using this for dehumidification. I have seen cases where we've overcooled by 10, 12 degrees, but basically these dehumidification units, and a good example is Quick Trip, if you're from Wisconsin, uses them. convenience stores, places where they have a lot of humidity to deal with. But they are available in most sizes. As you can see, we pack them in pretty tight. Here's your condenser coil. Here's your evaporator coil. You can have access to get in here. You have to take the roof off to get at some of these. But they are, they are packed in pretty tight. So just be aware of that. When you run into a reheat unit or a dehumidification unit, we can use either a 24-volt humidistat with just a set of dry contacts, or we can use a 4 to 20 milliamp signal to operate the system. This is a good example of a unit that's loaded up with a lot of accessories. So this one, if you look, here's your fire panel tied into terminal 5 and 6. Here's your dehumidification, number 7 to 12. You can either use a dry contact right here for dehumidification, or you can go to terminal 18 and 19 and use a 4 to 20 milliamp control to operate the dehumidification. If you operate the dehumidification off the humidistat, whatever the setting is on the humidistat is what controls the dehumidification. If you use a 4 to 20 milliamp control, and you can test that with your meter, then it's controlled off the options module, this potentiometer right here, okay? So if this is good at all the way counterclockwise, it's 40%, all the way clockwise is 60%, okay? And then here's what the different voltages relate to humidity, okay? Now, one thing to remember on the dehumidification units is they cannot operate below 40 degrees, and they will not operate over 100 degrees. So when you run these systems, cooling is typically the priority. So if you're in a cooling call, you're probably not going to be in a dehumidification call. Once the cooling call is satisfied, then you will go into a dehumidification call at that point. But again, if it's lower than 40 degrees outside, that will not dehumidify. So if the requirement is to dehumidify at all temperatures, this probably isn't the right unit for the job. So there are some limitations to what it can do. This is called the low bid, okay? So we're going to talk a little bit about how to set up the airflow on the different units, but we're just about an hour into it. Why don't we take a 5-minute break? And my time, actually 7 minutes, come back at 5 o'clock Central, and we'll pick it up from there, give everybody a chance to stream. Oh, wrong one here. All right, question. Does dehumidification coil use a diverting valve or modulating valve? Yeah, it actually uses a 3-way valve, kind of like a heat pump does. So it just diverts it from the main coil back to the other coil. So it energizes that during the reheat. Okay. Oh, 1 second, we'll get going here. All right, so we'll get going here. As I said earlier, that's called a low bid. We're going to talk about airflow and setup a little bit, and go over the couple different ways that we do this. Make sure you use proper curb adapter when you're putting these things in. So that's some stuff we've picked up over the years. All right, so a couple things that we need to know is we need to know our static pressures. When I get into the airflow and the setup, typically this ends up being the air balance guys issues. But we're going to go through this just to explain how this stuff works. So You need a manometer, some way to measure static pressure, whether it be electronic or magnehelic or, whatever works for you. And we need to look at the blower curves. Now, I realize this looks like an eye chart, but if you look at it, it kind of makes sense. So what we've got here is we've got a 12.5-ton unit, a YCD or H150, whatever it may be. And we look at the different RPMs available and CFM available, all the way from about a 0.1 static up to almost 2 inches of static here. So basically what this is telling us is that on this 12.5-ton unit, it comes with a 3-horse standard motor. If you need a low static drive, you may have to change the pulley, slow it down a little bit. Okay, but typically anywhere in this 0.3, 0.4, all the way up to about, I'll say 1.2, 1.3 inches of static. This static, the standard 3-horse motor will work fine. I mean, it will perform. So it's got a pretty wide range of performance. Once you get into the high static conditions, 1.4, 1.5, you may have to go to a high static drive accessory. And that would be, maybe a pulley change, max out the amps on the motor. And if you're in this range, you're probably okay. If you're in a real high static situation, you get up in this 1.8, 1.9, you may end up with a 5-horse oversized motor. Okay. So, knowing your static pressure is really important when you're setting these systems up. 90% of the time, that 3-horse motor is going to do the job. But you do have those real high static conditions where 5-horse may be what you need to overcome the static in the system. And that's basically what this chart is telling us. Okay, so how do we use that? How do we know what we're doing with the system? Well, first thing we need to do is figure out our static pressure. Now, on a Voyager, it's pretty easy to get the supply static. We need to get in this area right here, the return cabinet with the economizer closed. And we need to get in the plenum. And if you can't get to the ductwork just under the unit, on a Voyager, this panel right here underneath is actually part of the plenum. It's in the discharge air of the plenum. So you can take drill a hole in the panel here, in the door. Make sure you don't drill it from the outside in and hit the tubes though, be careful of that. And then you can drill a hole right here. And I get the question every time I do this, well, why doesn't the factory just put plugs in there? And it's like, don't know, I wish they would, but they don't. So it's up to us in the field to kind of put these in there. But we can get our static reading on a Voyager pretty simply by going in this compartment right here and right here and taking a differential reading, and we'll get our static. Okay, so this case we have a negative 0.2 and a positive 0.4. Our total external static to that blower is 0.6 inches. All right, so if you look at the way a unit is shipped from the factory, okay, on this 12.5-ton unit we're looking at, the pulleys come 3 turns open, okay? So on that particular model, we know that the motor or the fan is turning at 760 RPM based on that chart. And this comes with the unit. This chart comes with the unit. So at 3 turns open, 760 RPM, and a 0.6 static, 760 RPM. My brake horsepower, I'm using 2.33 brake horsepower on that unit. I am moving about 5,500 CFM if you follow the chart. And the chart's pretty close, okay? So at 5,500 CFM on a 12.5-ton unit, I'm running 440 CFM per ton. If you're in Colorado or someplace where there's not a lot of humidity, that's probably not a bad thing. If you're in Wisconsin or somewhere where there's high humidity and you want to do better dehumidification, you're going to want to change that. Okay, that's going to be a little bit too high. Usually the air balance guy is going to try to get you at 400 CFM per ton. So in order to change that, what I'm going to have to do is change the pulley speed. Okay, So if I take that pulley and I open it up to 720, or excuse me, open it up one full turn, now I'm at 720 RPM on the blower. And if you go back to the curve and a 0.6 static and you look at 720 CFM, now I'm moving 5,000, excuse me, 720 RPM. Now I'm moving 5,000 CFM, okay? So at 5,000 CFM, I'm at 400 CFM per ton, right? Now, if I want to do any better dehumidification, you know, say I want to get down to 4,500 CFM, that's 360 CFM per ton. And I can do that simply by, let me back up here, dropping my, opening my pulley to 5 turns. Okay, so if I had 5 turns, now I got 680 RPM on the blower. At 680, which is going to be right about here, I'm going to run 4,500. Okay, so just by changing that pulley, you can change that CFM, and that CFM is going to change your, excuse me, RPM is going to change your CFM. Now, the static is going to change slightly. As you change that blower, the static will move around a little bit. But basically, that's what we're doing with these charts. In order to get to the desired CFM, which would be probably 5,000, we want to be at that 720 RPM, 0.6 static. Now, if I were at a 0.8 static, I'd be at 810 CFM or RPM. Sorry, we'd have to change that to 810. Okay. Oop, 773. I'm in the wrong I'm in the wrong one here. So at 773 at a 0.8, I'd probably have to stay at that 3 turns open, maybe go to 2 turns open, and to, you know, change that a little bit in the other direction. So that's basically what these charts tell you. They give you the you know, you calculate static pressure, and then you'll have to look at your RPM and correlate that to CFM and make the changes accordingly. So that's what we're looking at when we're looking at a belt drive blower, okay, when we do our setup. Now, if I were up into this area here, 1.5 inches of static, as you can see, I'm at 945 RPM. Now I'm starting to max out that motor. I'm at 3.09 brake horsepower. So you'd have to probably look at an amp draw and see if I'm within spec on the amps on that. But this might start to becoming borderline where you have to go to that 5-horse motor. So again, it all depends on the static. We need to know what our static is to do the startup on these. Okay, any questions on the belt at all? Let's take a quick look here in chat. Nope, don't see anything. Okay. So I threw this in there. This is from the factory. The one thing I'll say about setting proper belt deflection on a rooftop is, if you guys are doing it now and you're not having problems with it, don't change what you're doing. You're doing it fine. This is just the factory's recommended way of doing it. If anybody's interested, they do make a belt deflection tool for this. But basically what you do is you measure the distance of the pulleys and divide by 64, and that's the amount of belt deflection that you need on that belt. Okay. So they make a tool, you know, after tightening the belt, you take the tool, you set it to, you know, whatever the setting is, the little diagram there. You set the large scale and the pound scale, and you read the amount of force it takes to deflect the belt. This is the part that I don't buy into. It says you got to go back at least 2 or 3 days later to set the belts again, and you guys all know that ain't going to happen. If you're doing a good job, you kind of get it to where you think it should be. Just give it a little extra. A new belt's going to stretch over a couple days. The biggest thing to make sure they're lined up. So, like I said, if what you're doing works, don't worry about it. But this is what the factory recommends and the belt manufacturers recommend for setting belt deflection. Okay. All right. That's pretty much on belt drive units, other than going into frequency drives, which we're not going to do tonight, there really isn't a whole lot to setting up these things, you know, if you understand the curve and how it works. What we're going to talk about now is BC plenum fans. And these are on our 7.5 through 10 ton Precedent models. And there's a picture of guys working on them at the factory. And if anybody knows Ethan, he's the guy supervising in the back there. So the reason we put this in here is when you go to the factory, if anybody's ever been to factory training, OSHA has rules about working on live electrical systems. And you're supposed to have arc protection, face shields, hot gloves, all kinds of other things. And I'm not going to get into the particulars on that. That's between, you know, most companies have their safety protocols in place. So I'm just telling you that when you're working on stuff over 200 volts, there are some additional rules you need to be aware of, and that do change what's going on in the field. One of the things that Trane American Standard has done is we've enclosed the high voltage panels now. If you notice that we put a door on there. So when you're working on this system, you're perfectly safe. When you open this door, just beware. You either have to have some personal protection or you have to have the power off at that point. So that's the reason I put these slides in there. Okay, so a plenum fan is basically a backward curve in centrifugal fan, okay? And it's on our 7.5, 8.5, and 10 ton models. And this isn't anything new. This has been on our equipment for at least 10 years now, maybe more. And it's used on a lot of other equipment around the country. One of the reasons we do it is to keep the weight down in the rooftops. You guys all know the rooftops are getting bigger because the efficiencies are being, you know, we're being told to get higher efficiencies. So in order to make the units bigger, they make them taller, and we need to take weight out of the unit so that the unit doesn't weigh more. You don't want to have to restructure a roof just to do a simple change out on it. So a lot of this technology is coming from the fact that we've got to keep the weights down and the efficiency up. So I usually get that question, so I thought I would just throw that out there. Now, this particular one is a backward inclined fan. Again, it paddles the air, it slaps the air. So if you look at this particular motor right here, it turns counterclockwise. Nope, sorry, clockwise. It turns clockwise looking at the end of the blade. So it pulls air in through the chute, the volute on the end, and it throws it out these paddles right here. So, and they are not reversible. They are self-correcting. So when you change the phasing on a unit, these will not run backwards. You can't make them run backwards, okay? So again, when you're doing your phasing, your phase monitoring, don't use the fan to see whether or not the unit's turning the right direction, because these will auto-correct their direction. But there's the inlet to the fan. They do have a fan switch up in here. It's a reverse flow switch. It's set for about 85 degrees. So if the air starts to get over 85 degrees, a lot of times we'll start to trip these units out. So just be aware that that's also in there. Okay, so if you look at our Precedent models, we basically have 5 different options. We've got the traditional belt drive option. We've got direct drive fan motors for the smaller units, 5-tap direct drives. We've got CTM or constant CFM fan motors. And then we've got the plenum fan for the electromechanical and the plenum fan for the Reliatel. The fan is pretty much the same between the 2 units, the bigger units, but how we control it and how we change the speeds changes a little bit on some of these electromechanical and Reliatel units. So when you get into the fans, the plenum fans, we also have 3 different boards. Okay, so there's a LCD display for the electromechanical units. On the Reliatel today, we have options modules that control the fan speed. And on the old original models that came out 10 years ago, we've got what we call an MMC board. And we'll show you how to set up all 3 of these before we get through this section. But again, the plenum fan has 3 different controllers depending on which rooftop you're working with. And going back to what we talked about earlier, On these units, on these plenum fan models, ventilation only is going to be 50%, okay? Economize is 65%, cool one is 65. So we've got different fan speeds for different options on these units. And we want to make sure that if you're doing a test and balance that you get it to 100% fan speed to do the proper job. So just be aware, we don't get 100% fan just because the fan is running, okay? Now, on the electromechanical units, we have what's currently called it's an engine control module. Basically, it's an LED display. And what you do is you can hit the set button here, hold that for 3 seconds, and then you can hit the plus or the minus buttons to speed up or slow down the boat, okay? On the options module, we have a potentiometer right here for fan speed control. And again, counterclockwise slows it down, clockwise speeds it up. So if it's a Reliatel model, it's going to be adjusted on the options module. And if it's the old control, the original control, the MMC, it's controlled by this dial, and this is located in the blower compartment usually. Okay, so how do we know what speed to set it at? And if you look at this chart, it's pretty similar to what we just went through with the belt drive. The difference is this doesn't need a high static drive kit because this unit can run anywhere from 0.1 to 2 inches of static pressure just by turning the dial. So we don't have to make any changes, but otherwise the chart is pretty much the same. The difference is we have to understand our static pressure, and we convert the static pressure to CFM, okay? And then the final step is we take the CFM and we convert it to DC volts, and that's how we adjust the fan speed on these. So, you know, the step on this one is static pressure to CFM and then CFM to voltage, or excuse me, RPM to voltage. All right, so on these models that on our particular rooftops, you can't go below 5 volts. I mean, these motors can go all the way down to a 1 volt input, but we operate ours between 5 volts and 7.5 volts DC. So if you look at the range on there, depending on the static, we can go anywhere from 1191 RPM to 1700 RPM. Okay, so I've had guys in the field say, oh, I'm just going to turn it on high and leave it alone, and that's usually not the best solution. You're going to get some awfully good air noise out of that particular motor. So, but those are the values on the system. As far as the setting up the airflow, it's the same as the Voyager. You know, we still have to start with static pressure. Okay, so we need to know what our static pressure is, whether you're using a digital manometer or magnehelic, whatever works for you, whatever your particular preference is. The difference on the Precedent units is we can actually get the static pressure on the supply from this panel on the end of the unit if it's a downflow model. And if it's in horizontal configuration, we'll have a piece of ductwork coming off of here, and we can get the static pressure right off of that piece of ductwork, okay? As far as return, same as the Voyager. We need to get in this area back here, you know, with the economizer closed and find out what our return static is right here, okay? So that's the big difference. Return here, supply on the other side in the supply duct. Add the two together. This is not a good picture. This is actually a Voyager picture, but add the two together, get your total static. And again, when you're taking a static pressure reading, if you're in test mode, make sure we're at 100% airflow, okay? If you're at 50% airflow, if you just brought the fan on, we're not going to get a good static reading, and we're not going to get proper setup on these. So, you know, pick a test mode that gets us into that 100% airflow. As far as airflow, this happens to be a 10-ton model. This particular unit tested out at a 0.5 static. Knowing that it's a 10-ton model, we need 4,000 CFM, in other words, 400 CFM per ton. And at a 0.5 static, we need to have 1,435 RPM on our motor to get the proper airflow. The factory comes set at the lowest speed, and if we don't touch it, we're going to be at 1196. In other words, about 800 CFM short. Okay. So we do have to make that adjustment. So to get it to 1435 CFM, you have to go to this chart right here, which comes with the unit. Find 1435, which is right here. And that gives me an equivalent voltage of 6 DC volts. So what I want to do at that point is change the DC output to 6 volts. Okay, and I'll show you how to do that in just a little bit. New example, this is a different example, which we're going to go from start to finish on. Again, our same 10-ton unit, but this time we're working with 1 inch of total static. And at 1 inch of total static, I need 1537 RPM. Okay. If I had 1.5 inches of static, I'd be at, to get to 4,000, 1629. And you can see as the static goes up, the RPM is going to go up on this unit. But for this particular case, we need 1537. I go to my chart, here's 1539, and it's telling me 6.5 volts DC. Okay, so that's my DC output I'm looking for. And I'm going to skip this slide, we're going to move on. If it's an engine control module, if it's the electromechanical unit, what you do is you go to this display right here and you hit the set button, and it should display MM1 and then 5.0 volts. Okay, that means it's at 5 volts DC, and that's the lowest speed it can be. So what I do is I hit the plus button until this display changes to 6.5, and that's telling me I have a 6.5 volt DC output. And then I hit the set button and hold that for 3 seconds, and the blower set, it should speed up and you're done. The fan is all set on this one, okay? If it's a options module, if it's a Reliatel unit, you're going to turn this potentiometer until the blower speed gets to be where you need it to be. Now, on this model, there's going to be a pigtail hanging out of the bottom of the options module, and it's going to have a blue wire and a yellow wire. And you plug your DC meter into here, set it for DC volts, and you go back to here and you turn this dial right here until the voltage reading on these 2 wires is at 6.5 volts DC, okay? 6.5 volts DC is 1539 RPM. And once you get to that output voltage, that unit is set. It should be good to go. The last control that we have is the old MMC controllers. And this is the same thing. You put your meter on here, DC volts. Turn the dial until this meter reads 6.5 volts DC. And once you're at that point, you're good to go. It's all set. Now, these controls are no longer available. So as they fail in the field, if you guys run into them, as they fail, what you're going to get is you're going to get this controller to replace it, okay? So then you'll be setting it up the same way, you know, just setting the DC voltage on this display right here. Okay, any questions on this particular portion of it? I'm going to look at chat here real quick. Don't see anything on here. Now, I want to point out one thing before I move on. Here we go. Oh, here we go. If you look at this chart right here, we're running at 400 or 4,000 CFM. Again, 400 CFM per ton. So what if I want to go to 4,400 CFM if I'm in an area where I want more airflow? Well, then what you do is you go to the 4,400, and it's now 1654 for RPM. 1654 puts me up here at about 6.75 volts. 7 volts maybe, okay, in that area. So again, you can raise that airflow. Or you can bring the airflow down to 3,600, which would be 360 per ton if you want to do better dehumidification and operate that unit at 1423. And 1423 is going to be about 6 volts. Typically, in my experience, most jobs that I've been on, it's between 6 and 7 volts is where you end up in most cases. But you can play with it. You can bring it up. You can slow it down. It's real simple to do. Just a simple change on the board. So, but any questions on that at this point? All right, take a quick look here. I don't see anything, so we're going to move on to the next one. Now, the reason I put this on here, never use pump down on a microchannel condenser. They will rupture. There's a lot of microchannel that's come out in the condensing units as well as the rooftop units, and you don't want to pump down a microchannel system. It will cause you problems. They can't handle the pressure. So if it's in microchannel, a lot of guys used to try to hold down the contactor, pump the liquid back in the condenser. That's a no-no. We've got a low pressure switch on these that won't let you do that anymore. You can pump back down to probably about maybe 30, 40 pounds, and beyond that, it's not going to let you do it because the coils are not going to handle that kind of pressure. So again, pump down, do not do it on microchannel systems, okay? This is another one. If you guys want this particular bulletin, let me know. It's microchannel coil servicing guidelines. It's probably another good one to have if you're doing service in the field. I'm not going to spend a lot of time on it, but it is available. Basically, if you're going to use any coil cleaners, they want you to use a pH neutral balance on the coil cleaner. So, like evap green or something chemically stable or at a pH of 7.5 to 8 usually works for you if you're going to do any kind of chemical cleaning. The other thing that I wanted to put in here is that if anybody has not done Odyssey system, they do not come with valves anymore. You have to order valves separately. And again, part of that is because of the pump down situation. So the suction and discharge valves are not shipped with Odyssey systems. They come with plugs and tubing. You have to add valves if you want valves. So just be aware of that. Okay. The other thing that I've got, if you guys want a copy of this, it's our low leak economizer and fault reporting. We've got this Trane Tracer UC400 with the I think it's a 924 control. Something fairly new. If you guys need information on this, again, shoot me an email. I'll send you this bulletin also. All right. So what I want to do is I want to get into rooftop charging. Because that's what, we're coming into the season right now. We want to check the charge, make sure everything's okay. And one thing to remember with microchannel control or condensers, we're using maybe 1/3 to 1/2 the refrigerant we used to use. So years ago, we'd have, say a 15-ton unit or 20-ton unit, we'd have 17, 18 pounds of refrigerant per circuit. Some of these new units only have 6 to 8 pounds in them. So they're considerably less with the microchannel, and the charge is much more critical than it used to be. Ideally, if you can weigh the charge in, it's going to give you your best charge. But if you want to look at the charge with your gauges on there to see if you're close, we'll give you some way to do that. So, and this happens to be a YSC 120, and depending on the liquid temperature leaving the coil, it's going to tell you whether we add or remove charge, okay? And then there's also system 1 and system 2. So these are your typical pressures you should see on a system when it's operating with these leaving coil temperatures, okay? So when you get into the books, and as a matter of fact, a lot of the units will have these pressure curves on the unit. And it's kind of like an eye chart, like I said earlier, and I hope you guys can see this. I hope it comes out clear enough. But basically, you got to look at the charging and airflow on these. And basically, this is a 120 system one pressure curve. So in other words, this is one compressor running the first stage compressor based on proper airflow again. So before we start looking at the charge, let's make sure that the filters are clean, the belts are tight, whatever, everything is doing what it's supposed to do. And basically what this is telling us is that at 75 degrees outdoor temperature and 74 degrees indoor temperature, you cross the lines right here, and I should be seeing about 125 on the suction line and probably 340 on the discharge line, okay? If it's 95 degrees outside and it's really hot inside, if it's 85 degrees inside, I'm gonna see maybe 155 on the suction line and maybe about 4.25 on the discharge line. So that's basically how these works. And again, this is system one, okay? Now, if you go to system two, here's your pressure curve on system two, and it's gonna be slightly different, okay? So if I'm at 75 degree outdoor and I'm at 75 degree indoor in this system, I'm going to be looking at about 135 and about 375. So if you guys remember, that's a little higher. The systems are affected by each other when they're running. So they may not be the same on both sides, okay? Questions on that, or? If you're at 95 degree outside and 86 degree inside, you're going to be at about 165 and 450, 440, somewhere in there. So again, the first stage and the second stage may operate differently. If one's running it by itself, or if both are running together, the pressure may be a little different, okay? Questions on that? Okay, all right, I don't see anything, so we'll keep going there. All right. Let's see where I'm at here. Okay, I think I was right here. Okay, so with both compressors running, if you're running, you should be running in this range depending on the liquid leaving temperature. So if you want to add or remove charge, it's based on the liquid leaving temperature, and that's because the microchannel has changed how we do things. We're not charging by subcool. We're charging by this chart. We need to follow this chart when we're talking about microchannel control. So again, look at liquid leaving temperature and your pressures, and either remove or add charge based on these numbers right here, okay? And that's with both compressors running. And here's I can't see the screen here. A YSC 80, hang on, I gotta move this. What's it say across the top there, Keith? I can't read. Oh, here it is. 2 fans running. So I gotta move this screen here. I'm gonna put it on the bottom. Okay. So it also makes a difference when you get into the Voyagers, whether you have 1 fan running or you have 2 fans running. So you gotta, if you're gonna charge in cooler temperatures and you only have 1 fan running, oh, damn it. It's going to make a difference in whether you add or remove charge as opposed to 2 fans running, okay? So on the Voyager, if you look at it, you're going to get the option of, based on indoor airflow, 1 circuit, 1 fan running. Here are your pressures, okay? So if it's 55, these are low ambient conditions. If it's 55 outside and it's 80 inside, here are your pressures, 130 and 400, okay, with 1 fan. So if you have both fans running, you're going to be in higher outdoor temperatures because, remember we said earlier, 1 fan shuts off on the cooler days. So you're going to be in higher temperatures, and then your ambient, say if it's 85 outside and 80 inside, you're going to be running 130 and 350. So again, these are like eye charts. Here's a pressure curve for number 2 circuit with 1 fan running and 2 fan running. And the difference is, this is low ambient outdoor conditions. You see it changes the pressures a little bit. And this is high ambient, regular, hot cooling temperatures with both fans running. So when you get into these controls or into these charts, just be aware there's a half a dozen different charts in there. Just make sure you use the one that applies to that particular set of situations. So if it's 85 outside and it's 80 inside, that circuit should be running about 135 and about 360. So again, different charts for different units. And I know it's a little bit of an eye chart. It's a little confusing, but again, with microchannel, that changes everything. Now, if you're looking at an old system, conventional fin tube, copper tubes in there, charge it by subcool all day long or superheat if it doesn't have an expansion valve. But when you deal with microchannel, make sure you follow the charging curves. And again, if you're weighing it in, that's the simplest way to verify charge. If you want to just throw your gauges on and verify charge, make sure you know what's going on. Make sure we've got 1 fan, 2 fan, 1 circuit, 2 circuit, because it does make a difference. Okay. So I know that's a lot of information. Do I have any questions at this point? Let me look at chat here again quick. That makes sense, guys? I'm gonna move this back up here. Okay, I don't see anything in chat, so I guess we must be good to go. So, all right. Now, there's also on some of the older units, and this goes back to the R22 stuff, which would be anything prior to, I think we went to R410 in 2010. So prior to that, we had R22, and we didn't use expansion valves on a lot of our rooftops. This is not sharing right here. What's going on? Did those charging charts come up on there, Keith, when I was showing those?
The first one did.
Yeah, something happened to the feed here.
Yeah, it did not advance.
Oh, I'm sorry. You didn't see these? You guys didn't see these?
I did see those.
You did?
Yes.
Okay, so that was the fans. Okay. I don't know what happened here. We kind of lost touch. But anyway, this is the older units. We have kits. We have retrofit kits to change some of the old fixed orifice units over to expansion valve kits. If you run into any old stuff out there that is got plugged orifices or maybe it's not working right, we can put expansion valve kits in them. Couple things to remember is that this is a 15-ton unit. We only have a kit for the 10-ton circuit, okay? Same thing on this would be a 17.5-ton. We only have the kit that fits on the bigger circuit. Until you get into the bigger units, the 240s and the 300s, you don't get to switch both of them. But there are kits available if you want to switch from fixed orifice over to expansion valve on older equipment that you're having issues with. So, and that's what this is for. And if anybody has ever done it, you got to cut all these tubes off, cut the orifices out, and add distributors. It's a lot of work. 2010, we're looking at units at least 11, 12 years old now. Depends how much money you want to put into them, I guess. But that kit is available. We also have expansion valve kits for the Precedent models. If you want to convert them over to expansion valve, some of the older equipment, if we have plugged orifices. So again, if you need info on that, give me a call, all right? I'm going to go over economizers kind of quick. I know David just did a more in-depth class on them, but I just want to touch on them real quick. And it makes a difference on Trane, whether you use a 24-volt control or a DC control, But when you're looking at economizers, the primary, goal of an economizer is to provide free cooling. I mean, that's what they do. That's they bring in fresh air when the conditions are right. The secondary job is to maintain 50 to 55 degree return air temperature. They'll go to minimum position when the fan is on and try to maintain that temperature. I'm not going to get into microcontrols all that much because, you know, those are already 20 years old or better. But they did operate slightly different. I got a quick couple of slides on them. So one of the main things that I want to point out here is when you're using DC control, you know, 0 to 5 volt or a 32 volt DC Trane control, on an economizer, it can actually see the temperature of the space down to 1/10 of a degree. And if the space is in economized mode and it's reducing the temperature at 2/10 of a degree per minute over a 3-minute period, it's going to lock the mechanical cooling out and it's going to say, okay, we're doing all right. The economizer is going to be able to control the space. Let's not bring on the compressors. So when you have a DC control, it has a lot more logic built into it. It can make those decisions and basically lock out compressors. Whereas if you have a 24 volt control, it operates a little differently, which we'll get into here in just a minute. So using a CTI or using a 24 volt control on an economizer, of course, we're going to try to economize, okay? If you don't have a Y2 call, and a lot of guys, even though it has one compressor, will not put a Y2 signal in, it will never go to compressor. It has to have a Y2 call if you're using a conventional thermostat to get that compressor to come on if you need it, okay? So if you get a Y1 call and it can't keep up and you give it a Y2 call, what's going to happen is the economizer is going to need to go to 100% open until the air temperature rises above 55 degrees. Then the compressor will come on, okay? So until the economizer has been open at 100% and the mixed air temperature goes above 55 degrees, that compressor will not stage on. But if the air temperature does get above 55, it gives you the possibility that you could be economizing and running the compressor even if it's 25, 30 degrees outside. It's all based on that mixed air sensor. So the mixed air sensor really controls how the staging works on these units. Okay, so we have a mixed air sensor on the blower housing. Usually there or stuck in the back of the blower. That's your mixed air sensor. The outdoor sensor on the old Voyagers, again, was right there, was stuck in the corner post of the unit in those two locations. On the new stuff, on the Reliatel, the mixed air sensor is usually somewhere near the foot of the compressor. It's been moved around, changed a few times, but typically the mixed air sensor is right there at the foot of the compressor, okay? The older controls were Honeywell. The Reliatel has the Modbus. Again, here's the 24 volts hot and the Modbus communications. Electromechanical has gone away. We don't use Honeywell anymore on anything. The system has changed a little bit. Basically, on the control, if you're looking at the Reliatel control, we have the Modbus, we have the 24 volt hot common. We've got all of these settings in here, and we'll go over those in just a little bit. We've got remote potentiometer capability, and then we've got our feedback capabilities here, okay? The ABCD settings are now ABCDE settings. So if you look at the enthalpy, the outdoor temperature, the E setting takes us down to 55 degrees. It just depends on what part of the country you're in. If you're in, you know, I'm from Green Bay, 55 is where you want to set it. If you're down south where there's no humidity, some people economize at 70 degrees. 70 degree dry air feels pretty darn good. 70 degree, 85% hair up in this part of the country is not very comfortable. So again, it again depends on what part of the country you're in. When you get into the Reliatel book, again, if you want to troubleshoot the mixed air sensors and the outdoor sensors, there's charts in there that give you the different temperatures. And if you look, here we are, 10K at 77. That's usually the standard for these sensors. Again, same for outdoor sensor on most models, but verify it, based on your model. Okay. On the Reliatel equipment, the economizer's got a lot of good information. It'll give you fault codes, CO2 sensor, humidity sensor, temp sensor. It really tells you what's going on with the system and gives you that information. So the diagnostics on the new stuff is really pretty simple. It really tells you what's going on, okay? Moisture causes faults, okay? So if you see water damage, if you see moisture on an economizer module, you pretty well can guess that it's shot. It needs to be replaced, especially if you're having any kind of issues with the system. All right, so if you're going to change out electromechanical system, the old Honeywell converts to this kit 16682. Not too difficult to put in, but it does require a fair amount of wiring and wire changes. So if you want to make a note of that, if it's an old electromechanical system, this is the replacement kit for that system, okay? On the new ones, the electromechanical and the Reliatel look fairly similar. They've got the same layout, same components. And I'm just going to go through this real quick because, again, I said David covered a lot of this, but when you're setting up a standard rooftop, there's really three things that you need. You need an outdoor sensor, and that's the one usually in the foot by the compressor. Excuse me. And you need a mixed air temperature sensor, so that's MAT. Okay, you need that outdoor, and you need this mixed air temperature, and that's the bare minimum this system will operate at. Here's your ABCD, your enthalpy setting. And on these models, design is actually your minimum position. So counterclockwise is all the way closed, clockwise is all the way open. One of the things you're going to run into, especially on some of the smaller impact units, they have what's called DC volts, DCV, which is demand controlled ventilation. And one of the calls I get is that you turn the economizer on, it drives to wide open. This comes factory set to wide open from the factory. Just turn that all the way counterclockwise, and the economizer should close and then start to operate normally. So if the economizer is stuck open on startup, it's usually because somebody at the factory has cranked this all the way open, okay? As far as these LL and UL, unless you're using demand control ventilation, you don't even have to mess with these, okay? These are only for CO2 monitoring in the space. And if you don't have anything on DCV, if there's no input here, then you don't have to worry about LL, UL, or DCV. Nothing's going to operate, okay? Mixed air temperature, again, is for mixed air sensing. Exhaust fan, if you're going to use power exhaust, you can plug it in here. On the electromechanical model, power exhaust is going to be in a different location. It's actually right, I forget where they put it here. Power exhaust, where are we going here? Oh, I think it's right here. Yeah, EXF, power exhaust and ground. On the electromechanical models, it's actually a powered output. And on the Reliatel models, it's just a dry contact. So it's a little different for the electromechanical. If you're going to do enthalpy control, you're going to use an outdoor humidity sensor. You can use a return or outdoor air temperature, return air temperature. You can do return air humidity. As you plug in the different components, this economizer, again, will recognize the different components and react accordingly. So, but the bare minimum you're going to see on here is MAT. That's pretty standard on most units. All right, this is the old economizer. And the only thing I can tell you about these is if there's watermarks on it, it probably needs to be replaced. This is the old microcontrol. Goes back to probably 2002 and older on these. So these are set up by dip switches. Like I said, I'm not going to spend a lot of time on them because there's really not, we're kind of winding out of that particular control. But if you want to test them, you can. if you test these units and there's a 5-volt DC signal that powers this stuff open and close, but if you jump, yeah, here it is. If you jump CW to TR1, it will drive closed. If you dump CCW to TR1, it will drive open. So you can jump these from TR1 to CW to CCW to drive the motor open and close. Make sure the motor's working. So, and that's about all I'm going to spend time on the economizer. So, before we're kind of getting down to the end here, but I do want to make a couple things very clear. We do have phase monitors on all of our new equipment. And basically what this is there's a 24 volts in. It says Y in and Y out, but 24 volts hot, 24 volts common. And if the phasing is correct, and we monitor the phasing with these 3 leads right here, then it will power Y out. So if everything's good, the light should be green. When the phase monitor is at fault, it will be red. If there's no light on here and you have power on all of these, you got a bad phase monitor. It's time to replace the phase monitor. So the first thing you want to do is, if you're having issues on a new startup, is look at this. Make sure we got a green light, that it's good to go. Okay. And they hide these. They're not easy to find. So just make sure if it's a 3-phase unit, we got green for go on these. And again, this is just the internal wiring, shows how the phase monitor works. As far as rotation, if you want to check rotation on a belt drive unit, great. There's the arrow, tells it what direction you should be going in. The curve always faces forward on these when you're putting fan blower wheels in. And on a 3-phase motor, it will definitely make drive backwards, and if your phase. Okay. Before you leave a job on a 3-phase system, always put your gauges on. Make sure the compressor's pumping. If you guys have seen or heard one running backwards, you'll know it's noisy, it's loud, it doesn't pump, okay? I've also seen them run backwards on 1-phase units when the wiring got reversed, and we ended up actually turning the compressor backwards to start. So even though it's a 1-phase, it can run backwards if the capacitor's miswired or the run start windings are miswired. So, be aware. But on 3-phase, if it's noisy and it's not pumping, it's running backwards. They'll run that way for a little while, but not very long. So always check your on your unit. How do we change rotation on a 3-phase? Where are we here? Change any 2 power leads. Okay, so again, if you change L1 and L2, it should run the opposite direction, L2 and L3. Any 2 power leads will change rotation on the unit to make it run in the opposite direction. Remember what I said earlier, plenum fan units will not run backwards. You can't make them run backwards by changing the L1, L2. Okay, so don't use the plenum fan as your direction on these, okay? All right, one of the last things I want to put up here is voltage imbalance. It's very important. I would hope that when you guys are doing rooftops or starting rooftops that, we do a startup sheet. But voltage imbalance, it gives you inefficient operation, motor amperage. Windings will overheat. It can cause all kinds of problems. We've had cases where we've lost compressors and we couldn't figure out why. We started looking at voltage and we started looking at amp draw, and we found some imbalances, and that will definitely cause a problem in the system. You're allowed 2%, okay? If you look at this, once you get to the 2% and you start to go above 2%, the windings will start to overheat. So it's for every, I think it's for every 0.1%, you overheat by 8 degrees. So if you're off by 3%, you're overheating, it's 24, 25 degrees hotter than it should be. So, voltage imbalance is very crucial on a 3-phase system. Make sure that, especially if you're losing compressors, that you take a look at it. So how do we do that? All right. With the system running, we want to take a voltage, L1, L2 to L3, and of course L1 to L3 to find out what the three voltages are. We're looking for 2% imbalance. So in this example, if I've got a system that's the 207, 205, 211, I total up my voltages and divide it by 3. So 623 divided by 3 is 208. Okay, so then you do the math and you do the average, or excuse me, deviation to the farthest one. So it's 205 divided by 208 is 8.5, or 1.5% is our voltage imbalance, and that's good. That's an acceptable range. Okay. Now in this example, if we're on a 230 system, we got 221, 230, 227. We end up with 678 volts. Okay. Take that, divide it by 3, and then we take the farthest deviation, which is 221, and that's 97.8 or 2.2% deviation. So in other words, at that point, we are over 2%. And that's not acceptable range. We have to be less than that. Give me 1 minute, guys. Yeah. Here. I know it's worse, dogs or kids, but anyway, the joys of working from home. So anyway, this voltage is too high, or this imbalance is too high. We need to correct it at that time. So what can you do? You want to confirm, of course, proper wire size, line voltage connections, load setter distribution. Anything beyond that, get the electrician or the utilities involved. In order to change a load balance in a building, you have to start moving breakers and changing wires, and that's kind of out of our wheelhouse for the most part. Have the electrician get involved or the utilities get involved at that point.
Larry,
All right, I talked earlier about the meter lead kit. This is probably my only sales PR thing that I do. If you don't have needle points for your meters, it's probably a good investment, especially in this day and age. I wouldn't go anywhere without these. Last thing I'm going to put up here is a startup sheet. If you guys are working on Voyagers or Precedents, you're having problems with the rooftops, do a startup sheet. By the time you get into this, probably, halfway through it, you're going to see what the problem is. But get the voltage, get the power, get the compressor, the pressures, the temperatures, all that stuff. And the other thing, when you're doing a new startup or annual maintenance for that matter, take a look at the wire lugs. Make sure the wires are tight, make sure there's nothing loose. From shipment or temperature extremes, spades can become loose or corroded. It's all things that you should look at when you're doing a startup or a maintenance. Just give it the good once over. So that's all I've got for you guys today. I know it's a lot of information in a short time, but any questions at all, you can unmute and ask, and I'll stick online here for a little bit. I'm going to take a quick look at chat, see if there's anything in there.
there are 2 questions.
Otherwise, guys, thanks for your time. I appreciate it. And let's see, we got here a couple of chats. Okay, any way to adjust for the hood exhausts that are going on and off with sensors in the hood? I guess I'm not sure what hood you're talking about, the power exhaust on this or the economizer. And the second one is, will the phase monitor check for voltage imbalance? No, the phase monitor, there probably are some out there that will. The only thing the phase monitor does is make sure that all 3 legs of power are there and that they're properly phased, so they look for imbalance. And my email here, I'll message to everyone, is okay. So I sent my email to everyone. Write it down. If you guys want any of the literature, let me know. I can send you the voltage imbalance sheets, the startup sheets. I've got a package with all kinds of things, and I'll just send out whatever I have here for anybody that asks for it. So looks like we got them all covered here. So guys, I appreciate your time. If you have any questions, give me a call, give me an email, and we'll take care of whatever you guys need. But have a good evening, and we'll catch you later.